volume, in terms of mole, in terms of mass, right? In terms of, you can say the mass, volume in terms of number of moles, number of atoms also, number of molecules. For example, say from this from this chemical equation, valence chemical equation. So this is 1 mole of nitrogen combined with 3 moles of hydrogen to form 2 moles of ammonia. So in terms of mole, I am expressing this equation in terms of mole, right? So the reactant 1 mole of nitrogen combines with 3 moles of hydrogen to form 2 moles of ammonia. In terms of volume, in terms of volume means what? 1 volume of nitrogen combines with what? 3 volume of hydrogen. So we get what? 2 volume of ammonia. In terms of molecules, so this is in terms of mole, in terms of volume, in terms of number of molecules. So clearly, 1 mole corresponds to how many molecules? Na number of molecules, Avogadro's number of molecules. Here 3 moles corresponds to 3 Na number of molecules and what? 2 Na number of molecules. In terms of mass, in terms of mass, here the molecular mass of nitrogen is 28, 2 into 14, 28. So 1 mole of nitrogen weighs equals to what? 28 gram. Here 3 into 2 becomes 6 gram. And here it is 34 gram. So clearly from this, from the discussion, so we have come to know a quantitative relationship. So many quantitative relationships exist between the what? Reactant and products in terms of volume, in terms of mole, in terms of number of molecules, in terms of mass, right? And the calculation involving the quantitative relationship between what? The reactants and the products in terms of moles, in terms of number of moles, in terms of volume, in terms of mass, in terms of number of molecules, in terms of atom, etc., you know, are known as what? Stoichiometric calculations. So today we'll solve some of the PUIQs. Well, those questions were asked in NEET. Let's start. All of you, please jot down. One decimeter cube of carbon dioxide gas is passed Find the composition Find the composition of the gaseous mixture at STP. It is clearly given when one decimeter cube of carbon dioxide gas is passed over hot coke. The volume of the gaseous mixture after complete reaction at STP becomes 1.4 decimeter cube. Find the composition of the gaseous mixture at STP. क्या होगा? देखो कार्बन डाइऑक्साइड को लिया गया, राइट? कार्बन डाइऑक्साइड का वॉल्यूम क्या है? 1 डेसीमीटर क्यूब. क्लियर? इट इज दैट गैस इज पास्ड, उसको पास किया गया किसके ऊपर? रेड हॉट कोक. कोक मतलब इट्स ए फॉर्म ऑफ कार्बन, राइट? पास किया गया, उसके बाद पास करने के बाद क्या हुआ? रिएक्शन टेक्स प्लेस. So carbon dioxide is converted into carbon monoxide. Now you are asked to find out the composition of the gaseous mixture. If the, if the after complete reaction at STP becomes 1 point, if the volume of the gases, total volume of the gaseous mixture is 1.4 decimeter cube. Clear? So you are asked to find out the composition. So first you have to write the valence chemical equation. So what is that valence chemical equation? Carbon dioxide, CO2, and it is in the gaseous form. It reacts with coke. Coke is C. It is in the solid form. So what do you get there? You get this is 2CO carbon monoxide. It is in the gaseous form again. Understood? Here carbon dioxide reacts with carbon. So what is that? We have started with 1 decimeter cube of this gas. 1 decimeter cube of carbon dioxide. Finally, the composition of the mixture is, so that means which are the gases? In the chemical reaction, which are the gases? How many gases are here? How many gases are here? How many gases are here? 2. One is carbon dioxide, the other one is carbon monoxide. So initially we have started with carbon dioxide, and during the course of reaction the volume of carbon dioxide decreases, the volume of the carbon monoxide that is formed, it increases, right? Suppose, so from this, suppose x decimeter cube of carbon dioxide has reacted. So has reacted, right? When it has reacted, that means how much carbon monoxide is formed. So this is x decimeter cube. When it is reacted, we are left with what? The amount, the volume of carbon dioxide, 1 minus x decimeter cube. Decimeter 1 minus x decimeter cube, the volume of carbon dioxide that is left. And that time, how much? 2x volume of carbon monoxide is formed. Clearly, when you take 1 volume of carbon dioxide, 2 volume of carbon monoxide, what? 2 volume of carbon monoxides are formed. 2 volume of carbon monoxide, that are formed here. So when x volume of carbon dioxide reacts, 2x volume of what? Carbon monoxide is formed. So once x volume of what is x decimeter cube of carbon dioxide has reacted, we are left with 1 minus x volume of carbon dioxide. So total volume of the reaction mixture is how much it is? Total volume of reaction mixture, reaction mixture, what is it? 1 minus x plus 2x. and that is equal to given 1, that is equal to how much it is? 1.4 decimeter cube. 1.4 decimeter cube. And now you solve it. So 1 plus x, 1 plus x is equal to, this implies, is equal to 1.4. So this x is equal to how much it is? 1.4 minus 1, that is equal to 0.4 decimeter cube. 0.4 decimeter cube. So x is equal to this much. Now, so volume of carbon dioxide is how much it is? CO2 is equal to 1 minus x. 1 minus x means what? 1 minus 0.4. That is equal to 0. Something. What is it? Something goes wrong. But there is something wrong in this home page, and this, something, it's not working here. It's not working. It's not. Something wrong. A technical issue is there. So this is 0.6 decimeter cube. Right? 0.6 decimeter cube. Right? This is the volume of carbon dioxide. And when it comes to volume of carbon monoxide, so it becomes 2x, that is equal to, this is, that's 0.4, this is 1 minus 0.6, this is 2x, 2 into what, 0.4, that is equal to 0.8 decimeter cube. So the composition of the mixture, we have 6 decimeter cube of carbon dioxide and 0.6 decimeter cube of carbon dioxide and 0.8 centimeter cube of carbon monoxide. Right. So another one, you can, this is last time this question was asked in NEET 2026. Another one you write, the amount of glucose required the amount of glucose required to prepare 250 ml of m upon 20 aqueous solution right, is how much it is. So molar mass of glucose is given, mm of glucose is equal to 180 gram per mole. So there are four options. One option A, 2.25 gram. Option B, 4.5 gram. Option C, we have 0.44 gram. Option D, we have 1.125 gram. So which one is the right option? Let's calculate. So clearly it is given, m of 250 ml of m upon 20 aqueous solution. So what do you mean by m upon 20? M, capital M stands for molarity. 1 mole upon 20, right? So m upon 20 means what? Is equal to, this is 0.05 m. 1 upon 20 means what? 1 upon 5. 1 upon 2 means 0.5. 1 upon 20 means 0.05 m. M stands for number of moles of the solute present in a liter of the solution. Molarity, it is given, right? The molarity is given. M stands for the molarity. So first we try to understand m upon 20 means, right? 0.05 what m? M means what? 0.05 moles of the solute present in a liter of the solution. This indicates, so this means what? 0. Or 1000 ml of the solution. 1 liter means 1000 ml of the solution contains 0.05 mole of what? Of glucose. Solute is glucose. Understood? So we are asked to prepare 250 ml. 250 ml. So let's calculate how much, how many moles of what glucose is present in 250 ml of the solution. So 250 ml. So 1 ml of the solution contains 0.1 ml of the solution contains how much? 0.05 upon 1000, right? 1000 mole of glucose. Clear? Understood? Understood? So 250 ml contains what? 250 ml. 250 ml of the solution contains 0.05 divided by 1000 multiplied by 250. This much mole of glucose. Understood? So this is equal to what? 4. That is 0.05 upon 4 mole of glucose. And in terms of mass, 1 mole of glucose has a mass equal to its molecular mass. Molecular mass is 180. We multiply this thing by 180, 5 upon 4 into 180. So what is its value? 180 is equals to, this is 45. Yes or no? So 45 is multiplied by 5. This is 225. That is equal to 2.25 gram. 2.25 gram. Right? So the right option is, which one is the right option? This one is the A is the right option. A is the right option. Understood? Understood? M upon 20 means M stands for molarity. M stands for molarity means number of moles of the solute present. If I say 1m, it means 1 mole of the solute present in a liter of the solution. M upon 20 means how, M upon 20 means 0.05. Yes, sir. M, and that is equal to 0.05 what mole of glucose is found in 1000 ml of the solution, or in other words 1000 ml of the solution contains 0.05 mole of glucose, and 250 ml unitary method you can calculate. 250 ml contains what? 250 ml contains 0.05 upon 1000 into 250, that in terms of that 0.05 upon 4 mole, and 1 mole, the mass of 1 mole of glucose equals to 180. So this much of mole equals to 0.05 upon 4 into 180, right? So that is 45. It's multiplied with 5, that becomes 225. So we can place 2 decimal, right? From the right, it becomes 2.25 gram. Understood? Understood? Yes. So another numerical you may write, the right option for the mass of carbon dioxide So that was a question asked in the NEET re-examination this year, 2026. The right option for the mass of carbon dioxide (20 gram) of 20 percentage pure limestone. Limestone is option A 2.64 gram. Option B, we have 1.32 gram. Option C, we have 1.12 gram. Option D, we have 1.76 gram. Right. The right option for the mass of carbon dioxide, sorry, the right option for the mass of carbon dioxide produced by heating 20 gram of 20 percentage of pure limestone. What is the formula for limestone? CaCO3. Right? When you heat when CaCO3 is heated, first you write the balance chemical equation. पहले balance chemical equation को लिखना है. So when it is heated, what does it give? Calcium oxide plus carbon dioxide. Clear? So the right option for the mass of carbon dioxide produced by heating 20 gram of 20% is pure limestone. Clearly it is given. Right? How much it is produced? So clearly 1 mole of calcium carbonate, when it is heated, it forms 1 mole of carbon dioxide. What is the mass of calcium carbonate? Right, 1 mole of calcium carbonate has a mass equals to its molecular mass. Come on, 40 plus 12 plus, because atomic mass of calcium is 40, atomic mass of carbon is 12, oxygen is 16 plus 3 into 16. So that is equal to 100 gram. And here it is what? 12 plus 2 into 16, that is equal to what? 44 gram. So when 100 gram, clearly, when 100 gram of calcium carbonate CO3 is heated, 44 gram of carbon dioxide is formed. Yes or no? Understood up to this point? Up to this point, have you understood? Yes or no? Yes. So this is clearly CaCO3 is given when you heat it. So 1 mole of calcium carbonate produces 1 mole of carbon dioxide. In terms of mass, so 1 mole of calcium carbonate, calcium atomic mass is 40, carbon is atomic mass 12, oxygen 16. If you add all the atomic mass, masses of all the elements present in this compound, we get 100 gram, and it is 44 gram. So 100 gram of calcium carbonate is heated when this much of so 44 gram of carbon dioxide is formed. We are asked to find out by heating 20 gram of limestone. This is limestone, right? So 20 by heating 20 gram of 20 gram of, it is given, it's 20 gram of limestone. How much you are getting? From out of 20 gram of limestone, we are getting what? 44 gram. Out of this, 44 gram of CO2 is formed. Yes or no? Understood? So if the percentage of purity is how much it is? Sorry. This is, what is that? 24, this is 100, no? 100 gram. So 20 gram, out of 20 gram of limestone, 44 upon 100 into 20. Yes or no? That is equal to what? How much it is? Upon 5. 44 upon gram of carbon dioxide is formed. Right. So 20% of purity means what? What is the yes? 20% of purity. How much it is? Come on. 20% of purity कितना होता है? 20 gram of 20%. 20% is of 20. How much it is? 20 into what? 100. So this is equal to how much? 4 gram. Understood? So 4 gram. So this is yes, out of 20 gram we get what? This is 44 upon 5 gram of carbon dioxide. Understood? Yes or no? Are you getting the point? So that 20% of purity is what? How much it is? So out of 4 gram, Okay. Out of 4 gram, we have to find out how much it is. Come on. 4 gram means what? So this is out of 4 gram, that is 44 upon 5 into 20 into what? Into 4. This is 4, this is 5, this is 5 again. 44 upon 25. How much it is? 44 upon 25. 25 ones are 25. Yes or no? So how much it is left? 25 ones are 25. How much it is left? So this is 44 upon 19. 19 means what? 7. 1.7. 1.7 means 175. Still 15. So this is 6. 1.6 gram. 1.6 gram of carbon dioxide. Try to understand this. 20 percentage of pure, if you take the pure form of calcium carbonate out of 4 gram, how much you are going to get? So this much, right? So this is sir, done. Okay, one two or one more. I can take up one more. So which one is the right option here? Yes. Which one? The D is the right option. D is the right option because in the D option we have this one. D we have this option as well. One more question I can pick up. The number of moles of hydrogen, the number of moles of hydrogen molecules. So another one, the number of moles of hydrogen molecules, S2 molecules, are required to produce (20 moles of ammonia NH3, right, through Haber's process. Through Haber's process. Option A, what is given? Option A 40, option B 10, option C, that is option C is 20, option D is 40. So for yes, for Haber's process, you have to write the balanced chemical equation for the preparation of ammonia. Ammonia is prepared from the Haber's process. How it is? So when nitrogen is treated with hydrogen, the valence chemical equation, what does it form? Ammonia. Which in presence of catalyst like Fe, we get. So this is not a valence chemical equation, and now if you multiply 2, we get. So clearly the number of moles of hydrogen molecules required to produce 20 mole of ammonia, right? So clearly from the valence chemical equation, number of yes, from the valence chemical equation, so 1 mole of nitrogen combines with 3 moles of hydrogen and to form 2 moles of ammonia, right? So clearly there is a relationship between the number of moles of hydrogen and the number of moles of ammonia, right? So 2 moles of ammonia. So from this 2 mole of ammonia are formed from are formed from are formed from 3 moles of hydrogen, right? So 1 mole of ammonia is formed. 1 mole of ammonia is formed from how much? From how much? See, this is 2 moles of ammonia are formed from 3 moles of ammonia, hydrogen, right? Are formed from 3 upon 2 mole of hydrogen, right? So in the question it is given required to produce 20 mole of ammonia. So 20 moles of ammonia. To get 20 mole of ammonia, 20 moles of ammonia is formed from 3 upon 2 multiplied by 20. It becomes what? 30 mole of hydrogen. So the right option is, so this is this is right option is 30, 40, 10, 20. There is another option 30. 30 is there. D is 30. So D is the right option. D is the right option. 42. D is the right option. We have to go with D. Understood? This is a stoichiometric calculation. So with this note, let's wind up the session today. Thank you. Have a great day.